Hello guys, welcome back to Smart Interviews YouTube channel. I am 𝗨𝗃𝗃. Today we are going to start with the Codechef Starters 205 Division 4. Let's get started. Let's start with the first problem. The first problem is cute string. You're given a string s of length 3 is called cute if it satisfies these two properties. That is s1 equal to s3. That means the first and the last characters should be equal. S2 middle character should be equal to W. Okay, so it's looking like a very straightforward problem. If you're having like in middle, if you don't have W, or if first and last are not same, it's not cute. So it's like a very straightforward problem. If we go to the sample input output, so it is cute. Why? Because first and last characters are same and middle character is W, so it's cute. And here if you see first and last characters are same, but the middle character is not W, so it's not cute. So let's see it in code. So in the input format they are given only a string, so we'll take the string input. So before you take the string input, we need to declare our scanner class. Okay, there are no test cases here, only single character string s equal to then yeah, I need to check if my s dot, if my first character is equal to my last character 2. And yeah, they have mentioned that s is only of length 3, so no need to handle any other cases. And the middle character should be equal to W. If these things follow, then yeah, it's cute. In anything else, it is not cute. Okay. It works. Let's start with the next problem. There are n points on the number line labeled 1 to n from left to right. Chef is initially standing at k. Chef's goal is to reach point n. Okay, so we are having a number line from 1 till some point n. Let's say n is here 10. Okay, now let's say chef is standing at some point, let's say 7. Okay, so chef is standing here. The target is to reach 10, but there are some moves that he can do. The moves are like, he can move one step towards left if he's currently at x. He can move to a point x minus 1. That means he can move one step towards left. And the second point says that he can move one step towards right. That means x plus 1. So he can move one step towards right. And the other move which he can make is mirror his position about the segment 1 to n. This means if he is currently at point x, he will instantly move to point n plus 1 minus x. So let's say what it means is, let's say if chef is at 7, if I mirror it, chef will be like at position 10 plus 1 minus 7. So 11 minus 7 is 4. So chef is going to stand at 4 after mirroring at 7. But yeah, ideally it's not the correct position. Why? Because if I do this, chef is going far from the destination. So performing at this point, it doesn't make sense. So moreover, And yeah, the moves can be made however and any number of times. Find minimum number of moves needed for chef to reach. Okay, so we need the minimum number of ways. If I consider 7, I can simply go one step right, one step right, one step right. In 3 moves I will be able to reach 10. So for this case it is 3. What if the same case, instead of starting from 7, if I start from, some other point, let's say if chef is starting from 3, so going towards right is always not the correct choice. So what we can do is we can go towards left. Okay, what if I mirror here? What if I mirror here? If I mirror, I am going to be at 10 plus 1 minus 3, which is nothing but 11 minus 3, 8. So chef is going to be at 8. Then he can move one step right, one step. In 3 moves, he can reach. So, or I can do the same operation like one step left, one step left. And if I mirror it, I am going to be at 10. So that means number of steps to reach 1 plus 1 for mirroring. So number of steps to reach 3 from 1 is 2, and plus 1 for mirroring. So in this case also the output is 3. So there are two ways to solve this problem. One is going directly towards right. So in this case my answer is going to be n minus k, that's it, 10 minus 7. Whereas in such cases my answer is going to be, can I say directly k? Why? Because number of moves to reach 1 is k minus 1 and plus 1 move to do mirror. So it is going to be k. So minimum of these two is going to be our answer. Okay, let's see this in code. So in the problem, the input format as mentioned, you need to read number of test cases, and in each test case you need to read nnk. So in this way I can read, first I will read number of test cases, then for each test case I will read n and k. And my answer is going to be sys out maximum of k or n minus k. Oh, I had to take minimum, right? Minimum number of steps. Yeah, it works. Let's start with this problem, triplet maximization. So chef has an array A of length x plus y. The first x elements are 1, then remaining y elements are 2. The array satisfies that from a1 to ax it is 1, from ax plus 1 to ax plus y it is 2. It is guaranteed that x plus y is a multiple of 3. Okay, so till now it is like, so till now we have this many number of x and this many number of y, and x plus y is equal is, what we can say, is divisible by 3. Chef will perform the following operations. Let s be the set of integers. Initially s is empty. Chef also has a score which starts at 0 while the size of s is less than x plus y. Choose 3 integers ijk such that they follow this condition and none of okay present in S already. Then add max of all this to his score. So essentially, chef repeatedly chooses elements, all the elements, till he can't take more. This continues till each element has been chosen once exactly. So you need to find the maximum possible score of chef. So the constraints are too less. That means we can do the brute force for it. And coming to the example, if I take the first example, what does it mean? I have 0 ones and 3 twos. So that means I need to take any triplet I, J, K, and out of this, for the score, 2 is going to get added. I can't take then remaining 2 to get the answer. Why? Because I need to take the triplet, and this is already present in the set. So for this, the answer is going to be 2. Coming to here, there are 2 ones and 4 twos. So to get the maximum, I need to take the ones. I need to take the pointers like this. This is I and J, and this is K. Out of this, which is maximum 2. So for my score here, 2 is going to get added. The next triplets are going to be I and J and K. So K is always coming from the this side, such that I want the maximum to be 2, and the minimums will come from the I and J. So out of these three, the maximum is 2. Hence the output comes out to be 4. And we can't take any other triplet, so that's our answer. Coming to here, if you are having all 9 ones, so these 3 I can take, these 3 and these 3. So 1 plus 1 plus 1, output is going to be 3. Coming but to last, if you are having 5 ones and 1 2, so these 2 can be my I and J, this can be my K. So what it's going to be is, so here my score is going to be like, obviously 2 is maximum, then I updated IJ and updated K, which is going to be plus 1. Hence here also the output is going to be 3. So I hope you have understood. So basically you can just replicate what I have done here. So why? Because the constraints are very less. So you can take an array, a brute force solution, take an array or take an array of size n is equal to x plus y, take a array of size n, take I and j pointers at the starting, k pointer at the ending. Obviously k is going to be our answer. Then move your I and j pointers, then move your k pointer. You can do in this way. The time complexity here is going to be like big of n, extra space is n, and n is nothing but x plus y. You can do this, and obviously this solution will get accepted. But there is one more optimal solution. For this, you can assume it like, um, you have, let's say, an array having more number of, let's say, more number of ones and few twos, and one more array having more number of twos and less number of ones. So here, if you have understood the problem, we need to leave uh, 2/3 of the array. So that means this is not going to be the answer, 2/3. And yeah, what is the count here? 1 2 3 4 5 6 7 8 9 10. Okay, we need to add few more elements. Let's say 11 12. And same here, 1 2 3 4 5 6 7 8 9 10. Let's say 2 more here. Why? Because we need to maintain the length of the entire array to be even. So here I need to leave the 2/3 of the array anyhow. I can't select. I will be selecting maybe 2/3 in the sense. I need to select 4. So I need to anyhow remove 2/3 of the array. But I need to select 1/3 of the array. So I'll be selecting the last 1/3. Why? Because I want the answer to be maximum. And here also we can't select the first 2/3. We will be selecting only the last 1/3. So if you observe, obviously the last 1/3 will have more number of 2's. So in this case, what can I tell? If my count of 2, if it is greater than n by 3, n is nothing but x plus y by 3. If it is greater than or equal to this, then I can say that my answer is going to be, what can I say? I can say like my answer is going to be n by 3 into 2. So the 2's are going to be n by 3 and its value is 2, so multiplied by 2. In this case, where my number of 2's is less than 1/3, so my answer is going to be like, so basically this is the if condition and this is the else part. So my answer is going to be like, obviously all number of 2's y into 2. All number of 2's should be selected plus the extra ones which I am selecting, it should also be added. So it can be added like total number of ones minus 2 into n by 3. So this will be removed. So whatever leftover ones is, we are going to add it to the answer. Okay. So this is going to be the optimal logic. So this can be done in big of 1. Okay. Let's see in code. In the code, so we need to eat the number of test cases followed by the x and y. Now, according to our logic as discussed, if my y count, if it is greater than or equal to, so we need to define n. So n is nothing but x plus y by 3. So if it is greater than or equal to n by 3, then my obvious answer is going to be, 2 into n by 3. Else else in the remaining examples, in the remaining test cases, my answer is going to be obviously 2's should be added at any cost. So count of 2's y into 2, so no note of a bracket here, plus now I need to add the leftover count of ones. So it is nothing but total ones minus the which I am living, the number of ones which I am living, which is 2 into n by 3. Okay, and I need to add this up. Okay, so let's see. Okay, number of 2's into 2 x number of, okay, it should be x plus y. If I'm doing if I'm doing by 3 here, then I can simply keep n here. That would also be fine. So if I'm doing by 3 here, it makes my equations look more simple. Yeah, it makes my equation looks more simple. Yeah, it works. Let's start with this problem. Unreachable. There are n people standing in a line. The ith person from the left has a strength AI. It is guaranteed that AI will either be 1 or 2 for each person. And suppose person I is holding a ball, they can throw the ball to person J if and only if it divides I minus J. That means if a person having some strengths like this, if he wants to throw a ball, he can throw to this person. Why? Because one, if I write the distance 1, 2, 3, 4, 5, 6, 7, what is the distance between 2 to 4? It's 2. So he can, so they can pass the ball to here. And if I ask you, he can he pass the ball to 2 to 5? No, the distance is 3. So it is not possible to pass a ball here. Your task is to find whether there is a pair ij such that if person I is initially holding a ball, there is no sequence such that ball can reach to the j. So that means you need to find, is there any deadlock or not? Like, is there any loop or not? For example, if I come to this, in the test cases, you have given n and the n people having their strengths. If the ball is at this person, it can be passed to anyone. If the ball is at this person, can it be passed to anyone? No. So yes, there is a deadlock. And if the ball is at this person, it can be passed there, it can be passed there. So everyone can have a ball at any point. And if this person is having the ball, it can be passed to here, it can be passed to here or here. But if it is passed to here or here, it can also be passed to here. But if it is passed to at these 2 points, there is a loop. The ball can't again reach to these 2 points. So yes, there is a deadlock here. There is no deadlock here. Yes, no, yes. So this is going to be the example. How to solve it? So how can we solve this is, if I take an example, I think this would be a good example only. So you have understood, right? Some observations you can make is, if a of I is equal to 1, ball can be passed to any point. Ball can be passed to anyone. And observation 2 is, if a of I is equal to 2, and if they are passing to j, the condition will be like j minus I, the distance, whatever, absolute distance, should be divisible by 2. From this, I mean they should have same parity. Same parity I mean by index. They should have same parity index. So if the ball is at here, I can pass the ball here to all the, if I go with the indices 0, 1, 2, 3, 4, 5 and 6. If the ball is here initially, it can be passed to all the odd points, If the ball is at even, it can be passed to all the even points. Obviously, if it is 1, it can also be passed to the odd points, but if it is particularly 2, it can be only passed to the even points. So what does it mean? If it is having at least 1 1, that means if at odd places, if we have at least 1 1, and if at even places, if they are having at least 1 1. So if these two conditions satisfied, that means there will be definitely no deadlock. So if I call this as, let's say, check 1 and this as check 2, if these two are true, then there is no answer. There is no deadlock. If any one of this fails, it is obviously yes, there is a deadlock. Okay, let's code this up. In the code, as we all know, the input format says that Yeah, we need to also take the array, but yeah, we don't need the array. Why? Because we can directly get the answer. We need just two checks, check 1 and check 2. Both are initially false. For now, let's read the array elements. So if we are only going to consider ones, we need to find ones. So, but yeah, anyhow, I need to read the values 𝗟𝗔.next. And if my temp is equal to 1, check at which index is it. If my I, if it is like even, then that means it is even index. So for even, I will keep check 1. If at least I find one, if I at least find array value at least 1, then yeah, I will update check 1 as true. And else, obviously it will be at odd index. So check 2 equal to 2 at this time. At the end, if both are true, or I can say it as if check 1 and check 2, if both are false, not both are, if both are false, then I can tell that yeah, there can be no deadlock. So yeah, the answer should be yes. Otherwise, in any other case, it should be no. There can be a deadlock. There cannot be a deadlock if both are true. So let's try to run it. Okay, I think there's a confusion. If check 1 and check 2, okay, if both are having, then it should be no. If both are true, then it should be no. There was a confusion. Otherwise, yes. Yeah. Yeah, it works. Thank you so much for watching this video. I hope you have liked the content. Make sure to like, share and subscribe. And if you want to learn coding in depth, you can join our Smart Coder course. Thank you once again. We'll meet in our next video.